Hi everyone, we are talents from four different institutions, namely UNITAN, UTP, Agency Nuclear Malaysia, and ETN Innovations. Today, we'll be sharing on a new nuclear technology called nuclear battery. So, what actually is nuclear battery? So before we start, we just want to clarify that nuclear battery, although carries the term nuclear, it does not contain nuclear materials such as uranium, plutonium, and thorium. It refers to the nuclear reactions that is happening inside the battery. So I will let the next video to explain to you.
Nuclear batteries promise amazing power. So, what are the big challenges we need to solve first? So, the whole reason we're excited, radioisotopes pack a massive energy punch, way more than normal batteries. Okay, but what is one, really? It just takes energy from atomic decay and turns it straight into electricity. The basic idea is super simple. Step 1, a source emits radiation. Step 2, a transducer captures it. So you've really just got two main parts, the radioisotope source and the transducer that grabs that energy. If it's so simple, then why don't we have these everywhere? Well, the engineering is actually pretty tricky. All right, the biggest factor for efficiency is something called scale length matching. What on earth is that? Think of it like this. If the converter's too small, radiation zips right through. Too big, it's just wasteful. Picking the right radioisotope is a tough balancing act. You've got to juggle all these different factors. See, the total efficiency is all these numbers multiplied together. Any small loss at one stage gets magnified. Let's just look at transport efficiency. A ton of energy gets lost before we can even use it. And how you connect the source and transducer matters a lot. Mixing them together works way better than layering. And why is that? Because radiation shoots out in every direction. With a flat surface, half is lost immediately. Then there's the case. It's not just a box, it's for structure, containment, and of course, safety. For instance, even a safe isotope like Krypton 85 needs a heavy 8 centimeter lead shield. That's a lot. But these limitations aren't roadblocks. They're actually the roadmap, showing us where to innovate. So the big question is, which of these puzzle pieces is the most important one to solve first?
As you can see from the video, a nuclear battery is made of three simple components, and the mechanism is not difficult to understand. However, there are challenges that we need to address before we can use it. We need a scientific approach. Hence, we come with four key focus areas that we must address. Firstly, we need to come up with a better transducer to improve the conversion efficiency. Secondly, we need to develop a simulation model to improve the design. Thirdly, we need to be innovative in arranging the nuclear batteries so we could have more power output. And lastly, we need to formulate a new material to contain the radioisotopes, as safety and safeguards are always our top priority. This nuclear battery project was actually started in 2019 by Agency Nuclear Malaysia. However, it was halted in 2020 due to COVID-19. Only after 5 years, we have restarted the project. Fortunately, within a year, we have reached TRL4. So, what have we achieved so far to get TRL4? We assemble a naked nuclear battery using radioactive waste from Agency Nuclear Malaysia, and we put it on top of a commercially available transducer. We then developed a computational model using a software called FITS. We tested the model alongside with the real radioisotopes, and the results match. Now I will show you a video on how the experiment is being done. As you can see from the video, a Nuclear Malaysia staff carefully placed the radioisotope inside a container that is lined with lead shielding. As you can see, he is carefully putting the radioisotopes on top of a transducer and he closed the lid. And in the next video, you can see there is current flowing. As you can see from the numbers on the screen, we are able to record 0.58 nanoampere of current. So now with a successful proof of concept in the lab, next we would like to test the system in a real environment. So in doing so, we must continue addressing these key focus areas. As such, We have gathered the nuclear and also the battery experts in Malaysia. Not only we have talents from the research institutions such as UNITEN and UTP, we also have industry partner which is Etienne Innovations, who has developed a battery management system for drone. We also have advisors from Petronas and TNB who will give us some advice on the energy storage pain points. And we also get legal advice from Jabatan Tenaga Atom. In case you are wondering what we can do with this nuclear battery, actually a continuous reliable supply of energy without changing it is very important and even is a matter of life and death. One example is the pacemaker. A pacemaker can't afford to even stop working for a second, as it will put the life of the wearer at risk. We will also need nuclear battery in the environment that is challenging, such as in the Arctic, in the deep sea, in the desert. We also need nuclear battery for micro robots because this battery is small enough and can provide reliable long-term energy to the robots. We have a clear vision. Our vision is to have a nuclear battery designed by Malaysians, made in Malaysia by 2030. We have the plan, we have the talents. Can you be our catalyst?